I'm Anil Kumar. Welcome to my mathematics series with Amy. Amy is a bright student from London, UK. We have an excellent strategy to understand the concepts and bring them to you. What we are really doing is first getting into the details of every topic and then selecting the best questions which have appeared in past test papers. Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good. So, how is your math practice going on?
Yeah, good. So we're on half-term break now. So I'm just spending my days revising like topic by topic, and then I will try and find some papers where they have everything together. Because so far what I'm doing, it's exam questions, but just by the topics. So I'm already in the mindset to do it. But you know, when we do our things where we just randomly pick from each topic, that's definitely way harder. So I need to get back into doing some of that. But yeah, slowly, but it's getting there.
So, which topic are you focusing on? Can we take those questions?
Oh yeah, so the topic, I think we did touch upon the algebraic and functions, which I was doing, but the ones that I wanted to show you it was again a bit of variety, because that's the part I struggle on a bit. So I think it's just trig and a lot of things.
Okay, let's see that.
So, all right. Just get that out. That. There's a bit of sequences in here as well. I don't know, we went through sequences quite quickly at school, and there's just one part of it that I wasn't really sure. You know, when they have like the sigma notation and then the R underneath it, just that whole concept, I'm a little bit
okay. We'll look into that.
Okay, cool. Thank you. Yeah, so I don't know if there are so many on here, so we could start with
anywhere you want. You want to do this? Okay, that's fine.
Yeah.
So can you please read the question?
Yeah. So the shape shown is a pattern for a pendant. It consists of a sector OAB of a circle center O, of radius R, which is 18 centimeters, and an angle AOB, which is pi/3. The circle C inside the sector touches two straight edges, so OA and OB, and the arc.
So, Amy, how are you going to solve this question? How will you find the area of sector OAB?
So would you just use the formula half r squared theta and then plug in the values given in the diagram?
Yes.
So half 18 squared times pi over 3.
Pi by 3, correct? So please calculate this. You get 9,
how much? 54 pi.
So 54 pi is the area of the sector. What is part B?
The radius capital R. You want to find the radius capital R of the circle C.
Okay. So basically, let's say this is your radius, right? This is what you need to find. So you can do a bit of construction. You can join O with C, right? So when you join O with C, this angle right there will be what? Half of pi by 3, right? Which is pi by 6.
Pi over 6.
So because these triangles, both of them will be right angle triangles, since tangent and the radius will be at right angle. Is that clear to you?
Yeah.
So you have a right angle triangle in which you have one of the angle as pi by 6. So now, if I extend this line, in that case, the total length, let's say it meets at D, right? So what is OD equals to? OD is the radius, right? Which is R, and which is given to you as 18, correct? So also capital R. So what is OC equals to? OC will be 18 minus the radius of the circle, correct?
Yeah.
O to C, right? We know the angle. Now, this is R, and we know two sides of this triangle. So one side is R, the other side is, let's call this as a point T, where it is tangent, correct? So what is sine of pi by 6? Will be R, this center over C, right? Will be CT, CT over the hypotenuse. Hypotenuse will be OC. So
Right,
sine
so
of pi
that's
by
5
6
over 6.
is in a special triangle, whenever you make that special triangle. So that is pi by 3, pi by 6, 1, 2 square root 3, right? So sine of pi by 6 is half. So you can, this value is half equals to c to t is r and o to c is 18 minus r. Do you see that?
Mhm.
Now you can cross multiply. So you get 18 minus r equals to 2 times r. 18 equals to 3r. So 18 divided by 3 is r. So r is equal to 6 centimeters. So we get r as 6 centimeters. Is that clear to you?
Wait,
Let me
I think I
summarize.
lost you.
Yeah.
I lost you at so I got sine pi over 6,
Yeah.
and then wait, did you times it by 18 minus r?
Yeah. Let me draw this triangle once again, right? So we have this triangle here, which is OC, and then that is tangent to this particular point. And in this particular triangle, this angle here is pi by 6. The side here is r, which is meeting the tangent. And the straight line, which we found, was 18 minus the radius, correct?
Yeah.
Now, that being the perpendicular side, this becomes the hypotenuse. So what is sine of pi by 6 or sine of O? So you can see that sine of O, which is pi by 6, is opposite side CT over OC. And this side is R divided by 18 minus R, cross multiply, find out. Is that clear to you?
Oh, okay. And in this case, CT was the radius, that's why.
CT was the radius, and therefore the total length O to D. So this is also radius, right?
Yeah.
But the total length is 18 because this is R is 18.
Makes sense. Yeah, now I got
18
it.
minus R is this length. So we solved this triangle. You understand?
Yeah, yeah.
And got the value of R. Okay?
Yep.
Perfect. What is part C?
So part C is the region outside the circle C and inside the sector OAB is shown shaded.
Correct.
Part C, find the area of the shaded region.
So you just take away minus pi r square, right?
Yeah. So
Which
sector
is,
area, subtract the circle area.
yeah.
Equals so 54 pi.
54 minus 36 pi.
Yeah.
So you get 54 minus 36 pi.
18 pi.
Yeah, that is how you
centimeter. No. Unit squared.
Centimeters. The centimeters.
Oh, it's in centimeters.
Radius is given in centimeters.
Oh, yeah.
So that is how you're going to do it. It's a very interesting question, right? You have understood, right?
I've understood. So it's about seeing triangles in these, I don't know, weird kind of shapes that they give. Sectors and stuff. Yeah, because that kind of helps a lot. Okay.
A lot of construction work. So you extend the point OC line to D. So you get one straight line where you can find what OC is in terms of R, the given length of 18. Right? And then also take a tangent, connect the point C and T, and then solve the smaller triangle.
Right.
So that is how you're going to do it. Great. Let's see the next question.
So, oh yeah, that does remind me. I had a similar question from school that was to do with this whole cosecant stuff. So later on, could we touch upon that? If that's okay?
We will. Sure.
Cool. Thanks.
You want me to do
this? Yes, please.
Okay. So we have to get sine and cosine. You can start from left side or from the right side as you wish. Show that left side is equal to right side. And there's a restriction, of course. Cosecant means 1 over sine. Right? So we just write cosecant theta minus sine theta. So 1 over sine theta.
1 over sine theta.
Sine theta is common. 1 minus sine square theta, which is
Cos squared theta.
Cos square theta over sine theta. Now you want to prove this to be cos times something. So let's keep one cos to and the other cos theta and divide that by sine theta. So you get cos theta times cos over sine is cot theta. Is it okay?
Yep.
Which is right hand side. And of course, you have the sine theta in the denominator, which is 0 for 180 multiples, right? And therefore, that is the restriction in this particular case. So that one was easy. So you got all that.
Yeah.
Now, what is the second part?
So hence or otherwise solve for x, which is in between 0 and 180, not included. And then where cosecant x minus sine x equals cos x cot 3x minus 50.
Okay, so basically, they're given the right-hand side terms here, and the left-hand side could be written as cos x sine x. You get the idea. So to solve this equation, we'll use what has been proved in part A, and so we can say cos x left-hand side is equal to cos x cos x times cot theta cot x is equal to cos x times cot of 3x minus 50 degrees. Do you see that? Let me erase this and write nicely. Can you, okay. So we have this cosecant x, right?
Do you want me to do that?
Yeah, that'll be better. Thank you. So this left side is cosecant x minus sine x, correct? We proved in part A that this is actually equal to product of cos and cot of this angle. So let me write this as cos x times cotangent x, correct? So we get this equation as equal to cos x times cotangent 3x minus 50 degrees. Is that clear to you?
Yeah.
We need to solve this within the domain 0 to 180 degrees. 0 is not included. Let's bring them together. So if I bring it to the left-hand side, then what do I get? I get this as cos x cot x minus cos x cot of 3x minus 50 degrees equals to 0, right? Now, you could have cancelled and written cot x equals to that and x equals to 3x minus 50.
Yeah.
But in that case, you lose one of the solutions. In this particular case, you're not really losing the answer because the domain is 0 to 180, but otherwise you would. So let's take cos x common. So you get cot x minus cot of 3x minus 50 degrees, correct? Equals to 0. So that gives us two solutions. One of the solution is that cos x is equal to 0.
Wait, so a quick thing.
Yes.
How come you chose to take cos x out? Is it because
common factor.
Cot is also common.
No, cot of x, and this is cot of 3x minus 50.
Oh, can't you just take...
different? Yes.
Oh, okay.
So when cos x is 0, so what do you get? 90, right? So cos x graph is kind of like this. Cos x is 0 between, we are only looking for between 0 to 180, correct?
Yeah.
So it is 0 at 90 degrees. So 90 degrees is one of the solutions. So you see, if you would have cancelled, then you would have lost that answer.
Right.
The other answer is solve. The other answer is we'll solve for the other factor. So in that case, x is equals to 3x minus 50 degrees. Bring them together. So 50 equals to 3x minus x, which is 2x. So 25 is the value of x, right? In degrees.
Wait, so how are we trying to make the 3x minus 51 equal to 0?
Equals to x.
Oh.
Because the argument should be the same, right?
Right.
So when you do that, you get the second answer, which is 25 degrees. So x is equals to 90 degrees and 25 degrees. Is that clear to you?
I've never done questions like that. It's really weird.
Mhm.
Where they say like cot x minus like another one. That's why I didn't know how to make that bracket equal 0.
Yeah. Because both things,
Mm.
yeah. Cot A is equals to cot B means A equals to B, right?
Oh, right. Okay.
Right. Now it was only given within the domain 0 to 180, right? Therefore, in
Yeah.
that domain, those were the values which we got as the right answer. You should
Oh,
also
I see.
remember that cotangent has a period of 180 degrees, correct? So it repeats after
Yeah.
180. So you could find multiple answers if the domain was wider or more.
Right. So you
By
just add
adding
180
getting
to the
180.
value.
And
Yeah,
then, working around it, correct?
And then with cos, you would just add 360.
Correct. So this question
Oh.
actually could have been very difficult if part A was missing. Think about it. Because then it was cosecant theta minus sine theta equals to that portion, right? So it was slightly tricky actually.
So
But yes,
if that part A wasn't given, you would just have to solve like a normal identity, just ignoring the 3x minus 50 and trying to make the right-hand side in
No,
terms of cos.
you
Oh,
will do the same thing. The left-hand side you will simplify and write it in this product form. You will get
okay.
that result. But the thing is, in your case, they kind of guide you towards the solution. That's what I'm saying.
Right.
So you are never lost. You know exactly which path to follow and get the
Oh, I
solution.
see.
Yeah.
Right. Okay.
But if that is not given to you, then first thing is what path to follow. That is the first thing, correct? Where somebody can get mixed up.
Yeah, I see. Okay. Yeah, that was kind of tricky.
Yeah.
I don't think I would have got that one. So yeah, I've learned a lot from that one. So the part A was nice and straightforward because you're just using your trig identities. But the part B, it's using part A's answer they've given, substituting it back in as the left-hand side of the second equation, and then solving. But when you solve, it's about moving. If I saw so I would have written the first top part, but I would have definitely done some cancellations and lost answers. Yeah, I would have done that or something,
Yes.
or something wrong like that. So it's about moving the whole thing and taking cos x as the common factor between them. And also, I thought you could take cot, but you can't because the values are completely different.
Yeah, they are.
So okay, makes sense now.
Perfect. Let's move on. Take the next question, please.
All right. So yeah, I think this is also like what we just did, so I don't mind moving on.
We can skip. Yeah.
I think this one was okay as well. We can start. Oh yeah, here. That's where the geometric thing was, so you can discuss that.
Sure. Okay. So you want me to do this question number 4?
Yes, please.
G of x is 2x plus 5 divided by x minus 3 greater than or equal to 5 is the value of x. Okay. Find G of G5. So that should be simple. G of G5. Yeah. So G of G5. So basically substitute 5 here. So you get G of, when you substitute 5, you get 2 times 5 plus 5 over 5 minus 3. Is it okay?
Yeah.
So we get G of 2 times 5 is 10, 10 plus 5 is 15 over 2.
7.5. Yeah.
7.5. So plug in 7.5 now. So which is equals to 2 times 7.5 plus 5 divided by 7.5 minus 3 to get your answer.
So I got 40 over 9. It's a really ugly number. It's just 4.4 recurring. So just keep in the fraction. Yeah,
keep that answer. That's fine. Not a problem, right? So 14, 5, 19. Yeah, maybe. Okay, that's fine. So anyway, you understood the process, right? State the range of G. So state the range of G. So this is basically a rational function, correct? So
can we sketch it?
Yeah, that's a good idea. Let's sketch it, right? Perfect. Yeah. Okay. So vertical asymptote at 3.
Horizontal asymptote at y equals 1.
2.
Oh, 2. Yeah.
Ratio of leading coefficients. Is that okay?
Yeah, 2x divided by x. X equals 3.
Correct. Now, since they have given you that x is greater than 5, do you see that x is greater than 5? That is a restriction. So they are not really looking into the left side of x equals to 3, correct?
Right.
So when you plug in 5, the value which you get is this value. This is, oh no, let's plug in 5 and see what is g of 5.
It was 7.5.
No, g of 5, 7.5, right? You got this value. So at 5, we get a value 7.5. So make a table, because now we know this side of the graph, actually I haven't given you much room there. It is kind of like this, right? So, I mean, so 5 was the minimum value. Let's plug in 6 or 7. If the value is larger, so it's here, right? So it's going like this. Do you understand?
Yeah.
So the behavior, we know it is going to approach y equals to 2. Is that clear?
Right. As it approaches, yeah, tends towards infinity.
Yeah, yeah. So it approaches 2. And therefore, state the range of g. So the range of g is that definitely it is greater than 0. Because, oh, sorry, greater than 2.
Greater than
that
2.
is your horizontal asymptote, but it is less than equal to 7.5.
Yeah. Perfect.
Okay.
Included because the domain 5 was included.
Yeah, 5 is included. That's why this is included. But the horizontal asymptote never crosses.
Yeah.
So we got that part, right. Now you need to find G inverse and stating its domain. Now, since the restriction is given to us, let us be very clear about this. We have the function g of x, where the domain of this function is what? Domain is that x is greater than equal to 5, and the range is, let me write down, range is between 2 and equal to 7.5. Is that okay?
Yeah.
Now we're trying to find the inverse of a function. So let's write down domain and range even before finding the function. Do you understand?
Right.
So we'll write this.
Because it's already a given.
Yeah. Domain will be now flipped, right? So we'll
say
x,
g of minus x has been between 2 and 7.5.
2 is not included, right?
Yeah.
And 7.5 is included. And the range is y greater than equal to 5. Is that clear?
Yeah.
X, this is x, right? Is that clear to you? So that is the domain range for your inverse function, correct? Now, second part is to find the inverse function. So basically, we'll swap x and y. So we'll rewrite this equation, which is given to us as y equals to 2x plus 5 over x minus 3. So when you swap, you can write what? You can write this as x equals to 2y plus 5 over y minus 3, right? Now you cross multiply. X times y minus 3 equals to 2y minus 5. Open the bracket. So you get xy minus 3x. Bring the terms together, minus 2y, right? You can keep 5 on that side, doesn't really matter. We need to find what y is. We need to basically isolate what y is, right? So taking y common, we get x minus 2 and minus 5 plus 3x. I'm taking this 3x on the right hand side. So y equals to 3x minus 5 over x minus 2. Is that okay?
Yeah.
So we can write g inverse of x is basically equal to 3x minus 5 over x minus 2, where this time x is less than equal to 7.5. Do you see that?
Yeah, because you swap the, yeah.
And sorry, not only this, and greater than 2. It will not touch this. Do you see that?
That's the domain. Yeah.
So x is between these two values, right? So anyway, so we got this as a domain. Only when you write the correct domain, then they become equivalent expressions, otherwise not.
Right.
So it is very important to write that particular domain. So my suggestion is, whenever you do inverse, consider domain range first, and then get into the calculations of finding the inverse function. Is it okay?
Yeah, yeah.
Otherwise, you'll be so much engrossed in finding the inverse that you'll forget to mention the domain, and you lose 0.5 marks for sure.
Yeah, and I've seen questions where they would ask for like some values, and you end up putting just everything to do with the inverse because you've calculated it, but then you forget that the domain and range was there. So yeah.
So mention this domain in your inverse function.
So always write the domain and range of inverse before you start question.
Yes, no harm in writing y greater than or equal to 5 in this case also,
Okay.
right? Because that was given to you. So it's a good idea to write that also, right?
Yeah.
Yes. Next question.
That's important. Okay. So question 5. So yeah, this is the part that I didn't get, this whole sigma notation stuff.
Okay. Sigma notation is a short form of writing summation, right?
Yeah,
Adding a series,
adding
for
everything.
example, that you
Mhm.
understand. So in sigma notation, one thing I'll recommend is some formula are very important. Like what is sum of natural numbers? N into n minus 1 divided by 2, right? Or n
Right.
minus 1 divided by 2, whatever. That formula should be known to you, right? What is the sum of squares and all those things. So first make a list of those formulae. Is it okay?
Oh, okay. Yeah, because I can feel myself getting all jumbled up with the formulas, especially with this whole sequences section.
Correct. So here you need 2 formulae, well, rather 3. So let me just split this and write nicely what this is. So it is sigma of first term r equals to 1 to 16, right? And the first term is 3. Plus, again, we are adding to this r equals to 1 to 16, the second term, which is 5r. Is it okay? Plus the third term, which is again the sum from r equals to 1 to 16 of another series, which is exponential series. Do you see that? And that
Wait,
should
so-
be equal to, yes.
Sorry, but so what does the whole r equals 1 to 16 mean? The number of terms?
Number of terms. So you have to add 3 16 times. 3,
Oh,
3, 3, 3, 3. You have to add 5r for r values of 1. So when you put 1, it'll be 5.
Yeah.
When you put 2, it'll be 5 times 2.
Oh,
Then
I
be 5
see.
times 3, 5 times 4, till 5 times 16. You get the idea?
Yeah, yeah. Okay, I didn't really get that. Okay, I thought it was the total 16.
No,
So
no,
it's
no.
just the number of terms from 1 to 16. So yeah, because sometimes the r value is not always 1. It can be like 5, and then you start
Yes,
by
yes.
the 5th term. Yeah, that's
Yeah,
why I was getting a bit
Correct.
confused.
You may have to sometimes when you're using the direct formula, you may have to subtract 1 to, let's say r is 10. Then
Yeah.
from the sum series formula, you may have to subtract the sum of first 9 terms and use the formula
Oh.
directly. Is
Yeah,
that-
yeah.
Let's
Makes
use the
sense.
formula. It's not a bad idea. So 1 to 16 means what? There are 16 terms, right?
Yeah.
So if I add 3 16 times, what do I get? I get 3 times 16, right?
Yeah. So 48.
Plus. Now this is a series where r, we could write this as 5 times, r is 1 plus 2 plus 3. Do you see that? 1 plus 2 plus 3 plus so on till 16.
Oh, to 16. Yeah.
That is what it means. You add 5 times 1, 5 times 2, 5 times 3 till 5 times 16. If I take 5 common, then it is like adding 1 to 16 the numbers, correct?
Yeah, yeah.
And the third one is 2 to the power of r. So it is sum of, you remember the sum of geometric series? R to the power of n. So let me write geometric series sum is what?
8 times r to the power of n minus 1 over r to the power
R
of n minus, r minus 1.
So that's your formula. So in this case, you are given that the base is what? Is 2, right? If r is 1, that is your starting number. This series is what? This series is,
2.
let me write down series, 2 plus, this is for 2 power of 1, right? Then 2 square, correct? 2
4.
times 2, right?
Oh,
Then
okay.
2 times 3, right? 2 times 2 times 2. That is 2 to the power of 3, correct?
Yeah.
3 2s. Up to 2 to the power of 16. Is that clear to you? So number of terms are how many? Number of terms are 16, right?
Yeah.
Each is being multiplied by 2 and the first term is 2.
Yeah.
So when I substitute these sum of 16 terms, a is 2 for me, r is also 2 for me, n is 16 minus 1 divided by 2 minus 1. We get our formula, correct?
Wait, is r?
R is the times with which it is being multiplied, geometric progression. So that factor is 2.
Oh, yeah.
Correct? To
Yeah.
exponential 2 to the power of r. So now we'll apply the, what is 3 times 16? It's 48, correct? Plus 5 times sum of series. So that is how much? That is 16 times 17 times over 2, right? Sum of natural numbers is what? N times n plus 1 over 2, correct? You remember this formula? Very easy to remember. But that's the formula you should know to add this particular set of numbers up to 16.
So yeah, 16 times 17 over 2.
Divided by 2.
Yeah.
Plus, this we already got 2 times, let me rewrite this as 2 times 2 to the power of 16 minus 1 over 2 minus 1. Is that correct? 2 minus 1, of course, is 1. So now you can use calculator and calculate these values to get the answer.
So yeah.
So 8 times 5 is 40. 40 times 17. 47, 28 to 680, right?
680. Yeah. That quickly.
So yeah, I can do, because see, 2 to the power of 16 is like 2 to the power, let me do it. So 2 to the power of 10 times 2 to the power of 6, right? 2 to the power of 10 is 1024. You get the idea? 2 to the power of 10 is 1024.
You know that.
And then 2 to the power of 6, 64, right? So you can multiply and get, well, you have the calculator. Just calculate, and this is 1, right? Okay, calculate, get the answer. And then add them all, right? And get your answer.
680. 131798.
Okay. That is what you wanted to prove, correct? Do you see the same answer?
Oh, yeah. I forgot they gave it to you. My exam's great.
I also forgot.
We love it when the exam gives us the mark scheme.
So I like your papers because they actually give you the path and also the answer. So you cannot go wrong here, right? 100% you have to score.
Yeah, and it's even 4 marks, and they've given us the answer. Okay.
Correct. See, did you understand all this now?
Yeah. So yeah, this is the part I'm really like stuck on. Always, whenever I get to series and sequences, I don't know, I just feel a bit shaky in my head. And it was all because of the sigma thing. So it's actually not that hard. I think it's kind of just breaking down the formulas, which we know of. So the sum of sequences, the sum of natural numbers, 1, and then individually. I think because the sigma notation was outside and then it was bracketed inside with other stuff. I just need to think of it like you've written on the top. They are individual still. So when you wrote it individually, it was really clear to know what was going on. So yeah, I need to do that.
I'll share with you one of my playlists in which we have all these formulas, right? We actually prove these formulas using induction method, and that is also a good technique, which you will be doing soon, right? So go through that list. You'll get many examples using sigma notation, along with many useful formulas, sum of natural numbers, sum of square of those natural numbers, cube of those natural numbers, and so many other things.
Oh, cool. Right? Okay, I'll check that out.
Yeah. Okay, next question.
So part 2, it says a sequence U1, U2, U3, and so on is defined by UN plus 1, which equals 1 over UN, where U1 is 2/3.
Okay. So again, Amy, what was the question, please?
So show that the sigma of R equals 1 to 16. Oh wait, sorry, no, we've done that. Sorry, part 2. A sequence U1, U2, U3 is defined by UN plus 1, which equals 1 over UN, where U1 is 2 over 3, so 2/3. Find the exact value of the sigma of 100, well, R equals 1 to 100, and then UR.
So now you understand sigma notation. Basically, what we need is to find what is U1 plus U2 plus U3, so on.
To U100.
U1, correct. So are we given the U's? Yes, we are given. This is called iterative formula, right? So you know U1 is 2 over 3, right?
Yeah.
What is U2 equals to? They are saying U2 is 1 over U1. So it is 3 over 2. So when they say n plus 1 is 1 over UN, previous term. So they have defined iterative formula with the help of previous term, correct?
Oh, okay.
So this is your previous term. Or you can say this is your next term, either way. So next term is reciprocal of the previous term.
Oh, right. But won't that keep going 2/3, 3 over 2, 2/3, 3 over 2?
So this is very simple. So U2 is this. So U3 will be what? 2 over 3, correct?
Yeah.
So half of the terms will be 2 over 3. The other half will be 3 over 2.
Yeah.
So
That's
50-50, right? 50-50, correct?
Yeah.
So we'll say 50 times 2 over 3
Oh, and 50
plus
times 3 over
50
2.
times 3 over 2, right? Okay, 50 is common. Then you get 2 over 3 plus 3 over 2. Is that okay?
Yeah.
So 50 is common, 6 common denominator, 4 plus 9. Is it okay? So 50 times 13 over 6. Calculate. So you can actually divide
325 over 3.
whatever. 325 over 3 is your answer. Is that
Oh
clear?
yeah, they want exact value. So yeah, that. So
that
if it
is
was
how-
just if it was an odd number they were asking for, you just use that decimal and then solve the same way.
Yeah.
Yeah. Okay, cool.
Okay,
Oh,
great. Easy, right?
yeah. I did not expect it to be that easy. Okay. So yeah, that's important. So it's the reciprocal thing and then using that formula, which I haven't seen before. So I
mean,
need
you
to
can now
keep
use,
doing this.
share with me the trigonometry problem, which you said was similar but difficult for you.
Oh, yeah. Okay.
Yeah.
I send it to you. Can I stop sharing and then you can
Yeah.
pull up a board? Because it might take a while.
Okay.
Okay, I've got it here.
Yeah, I'll write it on whiteboard. Right. No problem. Correct. Yeah. What's the question?
So given that 2 sec squared theta
Yeah.
minus tan squared theta equals p,
Okay.
show that cosec squared theta.
Cosecant square. Oh, sorry. Yeah. Cosecant square theta.
Yeah, equals p minus 1 over p minus 2,
Okay.
where p is not equal to 2.
Of course, right? So P not equal.
Yeah, rational.
Makes sense. So, okay. So whenever you look into secant and cosecant, you should always get reminded with their Pythagorean trigonometric identity, which is what? Which is 1 plus
Tan squared.
tan square theta is equals to secant square theta,
Square.
right? So
Yeah.
you can write always secant square theta as 1 plus tan square theta, right?
Mm-hmm.
Or you could also think about secant square theta minus tan square theta as 1, right? Is that okay?
Yeah.
Taking tan square on this side. So coming back to the question, we have 2 times secant square theta. So I could write this as secant square theta plus secant square theta minus tan square theta equals to P. Is that okay?
Yeah.
Mainly because I could write secant square theta minus tan square theta as 1. So I get secant square theta. This is 1. So I'm writing this as plus 1 equals to P. Is that clear to you?
Oh, so you're not like subbing in. See, what I did was I subbed in the secant square theta as tan squared plus 1.
One and the same thing. You could do that. Even then you get the same thing, correct?
Oh, okay. I like
So
your
we know
method.
secant square theta minus tan square theta equals to 1. This is a very important relation. I'll show you the importance at the end of this particular solution.
Oh, okay. Yeah.
Let's focus on the solution, then I'll actually tell you how to use this. Okay. So we have secant square theta as 1 minus, we want cosecant, right? So let's write it in terms of sine and cosine, right? What is secant? Secant is 1 over
1 over cos squared theta. Yeah.
So 1 over cos square theta is P minus 1. Is it okay?
Yes.
I took 1 there. So we could write cos square theta is equals to 1 over P minus 1. Correct?
Mm-hmm.
This is in sine. So we'll write cos as 1 minus sine square theta. Correct?
Oh, yeah.
So what is sine square theta equals to? 1 minus 1 over P minus 1. Is it okay?
1 minus 1 over P minus 1. Yeah.
So we have sine square theta equals to cross multiply P minus 1 over P minus 1. Correct? Which is
p minus 2 over p minus 1, correct? Cosecant is reciprocal of sine, right?
Oh, yeah.
So that is how you could actually solve this particular question. Is that clear?
Oh, I was struggling so much on that question.
It is difficult question. It is not a very easy question. I mean, we did a lot of math here, right, to get to the right solution.
I don't know. I was just thinking like, all you need is your identities, you'll be fine. But I don't know. I think the way I did it after, I don't know. I think just starting off how you started by separating the 2 secant square theta into those 2, even though it's so simple, you would never think, would you, to do that? And then it just makes the whole equation so much easier.
Correct.
Yeah, I went round in circles with this one. Yeah. Because it wasn't really working. Okay.
Now I will actually show you how to use secant square theta minus tan square theta very effectively. See,
all right, okay.
Like difference of square. You remember a square minus b square is what? Tell me.
A plus b, a minus b.
Product. So we could write this as secant theta minus tan theta times secant theta plus tan theta. I'm not solving that question, but giving you ideas. So basically, you can always write secant theta minus tan theta as equal to 1 over secant theta plus tan theta. Do you see that? Reciprocal.
Yeah.
You could write secant theta plus tan theta as 1 over secant theta minus tan theta.
Minus, yeah.
Immediate. So this is such a good step. You could actually write it like this. And in that case, you can solve some questions very fast.
I feel like there's so many other identities you need to know, not just the ones they teach you, you know, these hidden ones that you can easily find from like difference of squares.
Derive from them,
but you wouldn't think of it while trying to prove something. You're never going to think that will equal that. That's for sure, 100%. So
Let me summarize here, right? So you said the right thing. We know, we just found that secant square theta minus tan square theta is equal to 1. That means secant theta plus tan theta times secant theta minus tan theta is equal to 1, or secant theta plus tan theta equals to 1 over secant theta minus tan theta. Very important relation. Always remember. Now, let me give you another identity, which is, you remember, what is a cosecant square? So tan cot square theta, we know cot square theta plus 1 is cosecant square theta, right? Now, here also, I could write this as cosecant square theta minus cot square theta equals to 1, correct?
Yeah.
And that means cosecant square theta plus cot, I mean, let me just do difference of squares, right? Equals to 1 over, following the same steps, cosecant theta minus cot theta. Do you see that?
Okay.
So from those identities, we get these additional results, which you can use in proving identities.
Yeah, definitely. So yeah, I would never have seen that.
Very useful.
It's really important. Yes. I'll just make a note of that. So yeah, those 2 difference of squares. So reciprocals and difference of squares are like super important.
Yeah,
I've noticed. Okay, cool. So yeah, I'll keep those in mind then, because like, you know, when we think of cot, you know how it as 1 over tan. It's good to also think of it straight as cos over sine, like as a separate identity instead of doing that second step. So just to go from that to that really quick. So like that, knowing these identities as well without doing that whole process makes it really, really quick. So yeah, I need to make a bank basically. It's a long list, but yeah, it's helpful.
So Amy, can you summarize today's learnings?
Yes, so we did a lot of like inverse trig kind of questions, which is just looking at seeing kind of your trigonometric identities, but from that trying to derive different ways of solving. So like the one we just did right now, I kind of use the standard identity and then subbed in what I knew was secant squared and then subbed in. But seeing the 2 secant squared theta, knowing you can write it as secant squared plus secant squared like that, you wouldn't think, but just writing like that made the other half of the equation equal to 1, which is so nice to work with.
Correct.
And then you can just go from there, because I was going roundabout in circles with this question.
Correct.
So yeah, that was kind of tricky. And then we did quite a lot of graph questions, and just from those ones, it was like, even before starting the question, whenever you see this whole thing about inverse of the graph, just immediately write down the domain and range, because it's already given in the question. You just swap them. So that's nice and straightforward, and it would prevent you from like drawing parts of the graph that maybe aren't included in the domain. So like we saw the question where it said x being greater than or equal to 5, you're not going to write other stuff up there or the rest of the graph, because they're only asking for x and greater. So yeah, things like that is really important to keep in mind. And then we learned a lot about the sigma notation for the sequences. So yeah, I didn't really get that, but now I do. So yeah, the terms 1 to 16, and then knowing your formulas, and then individually working with each part, as we saw in the question. So yeah,
that's great. So I hope that helps. Keep sharing your test
did
papers.
so much, sir. Thank you so much.
Okay,
that was really helpful.
All the best.
Thanks, sir.
I hope you learned from this particular video. Feel free to write your comments, share your views, and share questions if you have. You can also join us sometimes on our Zoom calls. You can send a request to me on the email address given here.